Hi, I'm Russell Parvez. I'm an assistant professor and soil fertility specialist for LSU Ag Center. Today I'll talk about reevaluation of fertilizer recommendations for soybean production in Louisiana. Under this topic, I'll cover two things. First, phosphorus and potassium fertility at different soil depth. And second, reevaluation of fall versus spring phosphorus and potassium fertilizer application timing. Let's start with the first one. Soil test-based fertilizer recommendations are very common and effective method across United States. Most of the land and university develop fertilizer recommendations based on topsoil nutrient concentration, that is usually 0 to 6 inch depth. This topsoil-based fertilizer recommendation is very effective, especially in fine texture soil, that is clay soil, where most of the nutrients are stratified on the topsoil. However, for coarse texture soil, that is sandy to silt loam soil, we often find no to low nutrient specific stratification in the uppermost depth. Here is an example. This photograph represents nutrient concentration across different soil depth. If you see potassium concentration, it is increasing as you go down to the soil profile. This is one of the main reasons that often gives us false positive yield response to potassium fertilization. That is, you sometimes don't see yield response to potassium fertilization even though your topsoil is deficient in potassium. This is because you may have a deficient potassium concentration in the topsoil, but you may have lots of potassium down to the soil profile that soybean roots can get the potassium and fulfill its requirement. So based on these findings, we hypothesize that both topsoil as well as subsoil potassium availabilities needs to be considered to develop a better fertilizer recommendation. So the objectives of our study was to evaluate soybean yield response to soil test phosphorus and potassium concentration at 3 different soil depths. For these objectives, we conducted 14 site years research in 2020. 10 sites were actually at research station and 4 sites were actually on the producer field. We have 5 different rates of phosphorus and potassium fertilizer that we applied at or before planting, and we took soil samples before we put out any fertilizer, and we took soil samples from 0 to 6 inch depth and 0 to 12 inch depth, and we did not take soil sample from 0 to 18 inch depth due to labor shortage. We also collected tissue sample and crop reflectance data at the R2 stage, that is blooming, and we collected soybean yield at maturity. Due to the time limitation, I will talk about only soybean yield. This graph represents soybean yield across soil test phosphorus concentration at 0 to 6 inch depth. Here is the x-axis, soil test phosphorus concentration in ppm, y-axis is soybean relative yield in percentage. So there is 14 dots, and each dot represents one side. So the red dots represent unresponsive side where we put fertilizer like a phosphorus fertilizer but did not see any yield response. The green and blue dot represents responsive side where we put fertilizer and see yield benefit. If we develop a critical concentration that represents 90 to 95% relative yield, that critical concentration would be 21 to 30 ppm, which is very similar to our current critical concentration that ranges from 21 to 35 ppm. So on the left side of the critical concentration, we have a deficient zone. On the right side of the critical concentration, we have sufficient zone. So on the deficient zone, we had 5 total sites, and out of 5 sites, 3 sites are responsive. So our critical concentration actually 60% accurate in identifying potassium or phosphorus deficient site. So if you have a deficient phosphorus concentration, you may lose up to 20% yield. So this graph represents the similar yield response, but at 0 to 12 inch depth. And if you develop a critical concentration that corresponds to 90 to 95% relative yield, that would shift little bit, and it ranges from 15 to 23 ppm phosphorus. And on the deficient zone, we see our accuracy is going little down, that is 50% in identifying phosphorus deficient site. So we are not improving our critical concentration or predictability by taking deeper soil sample. This is because phosphorus is highly immobile in soil, so we may need to take a shallower sample like 0 to 14 inch to get a better predictability or increase the accuracy. This graph represents soybean yield across soil test potassium concentration. Here is the x-axis potassium concentration in ppm, y-axis is the soybean relative yield. Again, the red dot represents unresponsive site and green dot represents a responsive site where you put fertilizer and see a yield response to potassium. If you develop a critical concentration, that would be very narrow because it represents from 90 to 95% relative yield, and it ranges from 100 to 120 ppm. But if you look at the current critical concentration, it varies with soil type and the range is very wide. But we don't see that trend in our research. So on the deficient zone, we had total 7 sites, and all sites are responsive to potassium fertilization. That is our critical concentration. Even it is narrow, but it was 100% accurate in identifying potassium deficient site. And if you are on the deficient site, if you don't put any fertilizer, you may lose up to 35% yield. So this graph represents the similar yield response, but for 0 to 12 inch depth. And if you develop a critical concentration, we did not see any shifting at a similar response. What the critical concentration at 0 to 12 inch depth was 100% accurate in identifying potassium deficient site. So let's recap the key points. Our preliminary data suggests that critical soil test phosphorus concentration at 0 to 6 inch depth was 60% accurate in identifying potassium deficient site. However, critical soil test potassium concentration at both depth were 100% accurate in identifying potassium deficient site. The current LSU Ag Center critical soil phosphorus concentration at 0 to 6 inch depth is still valid across all soil types. However, critical soil potassium concentration at 0 to 6 inch depth was accurate only for silt loam soil, but not very accurate for clay soil. And we did not see any trend in changing critical soil test P, phosphorus and potassium concentration between 0 to 6 and 0 to 12 inch depth. This research will be continued this year and next year. Let's move on to fall versus spring phosphorus and potassium fertilization trial. The main reason for this research was most of our producers still believe that they have to put both phosphorus and potassium fertilizer, that is TSP and potash, in fall because it takes longer time. It's a rocky material, takes longer time to dissolve and become available for plant uptake. And this is not true. You can put easily this both fertilizer in a spring, and if you have a rainfall, it will dissolve within a week actually and become available for plant uptake. Let's look at the results. We had two tests or two trials for this study. One at the Macon Ridge Research Station in Winsboro, and other one is the Northeast Research Station at St. Joe. We had 3 treatments, one like a check with no P and K, fall recommended amount of P and K, and spring recommended amount of P and K, and y-axis is the soybean yield. We see a yield response if you put fertilizer because it was a deficient site. Both sites are deficient, but we did not see any yield difference, statistically yield difference between fall application and spring application at both locations. However, we did see there is a 3 bushels yield benefit if you fertilize in spring rather than in fall. And this is because you have lots of time to lose some nutrient if you apply in the fall and it goes through the winter and there is lots of rainfall. If you have a sandy or coarse texture soil with low CEC, you may lose nutrient either through leaching or runoff. So our preliminary data suggests that also it was not significant. There is a trend of getting benefit from spring P and K application compared to fall application, especially for silt loam soils. With that, I like to acknowledge Louisiana Soybean and Grain Research and Promotion Board for funding this research. If you have any questions, please feel free to contact me. Here is my contact information. And thank you.
Sure. So for these two presentations, we're going to look at promoting and protecting soybean yield, both by seed treating microbes and managing red-banded stink bugs. This graph from the USDA does show that the positive trend that we've had for soybean yield, showing from 1991 to 2019. From about 29 years, we see that there's approximate 16 bushel per acre yield advancement. And from just looking at 2006 to 2020, there's about an 8 bushel per acre increase. So that's about on the trend, maybe a little bit above in the last 16 years or so. And this has mostly been done by advancing by breeding, but also improvement of agronomic practices. One of the ways that we have improved our practices is increasing our fertilizer use, but also protecting yield by protecting against abiotic and biotic stresses. Looking at the increase in fertilizer, this first graph is showing the percent of planted acres that we have applied fertilizer, showing the crop year on the x-axis and the percent of planted acres that we've applied fertilizer on the y-axis. So we see that, so the yellow line will be the sulfur, blue nitrogen, orange phosphorus, and then potassium. For sulfur, we have, since 2006, we have about tripled our percent of acres from roughly 3% to 10%. Nitrogen, we have increased about 10% since 2006. And for phosphorus and potassium, we have almost doubled from the low 20% to low 40%. And looking at the pounds per acre that we have applied, the sulfur and nitrogen has been about the same since 2006, but we have increased for potassium and phosphorus roughly 10 pounds per acre, 7 to 10 pounds per acre more now than we did in 2006. Looking at the total fertilizer applied for these nutrients, sulfur has increased a little bit since 2006. Nitrogen has about doubled in total fertilizer applied from roughly 200 million pounds to 400 million. And also phosphorus and potassium has doubled or more than doubled since 2006. Phosphorus starting at almost 800 million to now 2 billion pounds, total pounds, with potassium beginning at 1.5 billion pounds in 2006 to now a little over 3 billion total pounds being used. So certainly we have increased, doubled our fertilizer use since 2006. This is, associated with the 8 pounds that we have increased per acre. Certainly have increased our fertilizer use. So we can use seed treatments to protect against some stresses that we normally do, but in particular look at using biological seed treatments that can protect seeds, protect yield, but also can act as seed enhancers, hopefully have, for example, more efficient fertilizer use. So I am working with Dr. Ham from the LSU Ag Center, who works in the Department of Plant Pathology and Crop Physiology, and his information is listed here. I'm sure he's willing to answer any questions you have. In his lab, some previous research that he did was to select and screen beneficial bacteria in the soybean rhizosphere. So these are bacteria that's been shown to help protect against pathogens or other stresses, but also being able to use to have more efficient fertilizer use. There was some success in the greenhouse. Over 20 bacteria isolates have been found to help promote soybean growth. And now with the hypothesis that using multiple beneficial bacteria would provide an additive or a synergistic effect. So there has been additional screening where mixtures of 9 and 15 bacteria strains have been screened, and they have been shown to increase soybean growth and yield. And not just yield, but has increased the number of pods per plant and the total size and weight of each pod. So there's some promising results that we've seen. So moving forward, the objectives that we want to look at is to first maximize the shelf life of the biological seed treating materials. Also, let's see how they do in the field. Evaluate the effect, evaluate how they respond when you're actually in more real life situations, and also try to identify a minimum number of bacteria components that will help maximize the benefits, and then try to move forward to evaluate possible tolerance to drought and disease pressures. Looking at those a little more in detail, the first would be to develop a formulation method for maximizing shelf life. The previous studies have shown that freeze drying is the control, the most effective way to preserve the bacteria, but trying to look at testing various chemical solutions to see what is the best, most efficient way to preserve these bacteria components. And the viable bacteria cells will be determined, right before and 6 months after freeze drying, and looking at the survival rates of individual bacteria strains compared to the bacterial mixtures. And the freeze-dried formulation showing the highest survival rate will be compared with the freshly made formulation in the greenhouse. The second objective is testing these in a field, and these will be at 3 different regions in the South Louisiana, testing at the Ben-Hur Research Station in Baton Rouge. Also in the Central region, testing at Dean Lee Research Station in Alexandria, and in the North region at the Red River Research Station in Bossier City. And this will be tested with and or without application of conventional fertilizers. The next objective is to identify the composition of minimum number of components with maximum activity. It's not really feasible to test all possible combinations of the 9 and 15 combinations, but we'll test about 50 subsets of bacterial mixture, targeting 3 to 5 components in the greenhouse with 3 replications. And looking at subsets of bacterial mixtures will be designed primarily through avoiding overlapping species and biological activities. For example, only 1 strain will be selected from each species and each type of biological activity. And the next objective would be to move forward, begin to conduct pilot tests to evaluate the effects on tolerance to drought and disease pressures. In the greenhouse, be screening 2 sets of bacterial mixture. First, trying to induce in a drought condition, and then testing in the presence of the fungal pathogen Rhizoctonia solana. So all the tests will be conducted in comparison and in combination with commercial seed treating products. the main goals, of course, is sustainability, trying to maximize economic benefits through reducing inputs, and continue to develop seed treating materials to increase tolerance to adverse conditions, different soil types, pH, climate, biotic, and abiotic stresses. So I want to thank you for your time on this presentation, and my information is listed here. You're welcome to contact me with any questions.
All right, guys, this is Steve Brown. I'm the LSU Ag Center Research and Extension Entomologist for the state of Louisiana. And so I'm going to give you guys kind of an update and more of an explanation on kind of how we control and manage red-banded stink bugs in Louisiana. So, and I know I get a lot of questions about this, from guys all over the Mid-South. And we've dealt with stink bugs, especially red bandeds in Louisiana, since 2000. So fortunately, unfortunately, our guys in the state have really, they've got about 20 years of experience dealing with them. And so these are some of the lessons and some of the things that we do and kind of how we've evolved our management of red bandeds and kind of what guys do to help offset some of the issues that we see. And then also why red bandeds are so much more damaging than our other native stink bugs. So I'm going to go through that, and you can kind of see that on the slide I've got here. It's so red-banded stink bug feeding induced seed injury. So this research was conducted by D. Pieri and Panizzi. And so Panizzi is more or less the godfather of red-banded stink bug work. He's in Brazil, I believe, or is it either Brazil or Argentina? I think Brazil. And that's where red bandeds actually originate from, in South America. So a lot of the work that we reference in the United States, a lot of the biology, the things that we rely on to help us manage these stink bugs has actually been generated by this group down there. So, and this is some of their work. So red-banded stink bug probes significantly deeper. So at 2 millimeters versus 1.2 by the southern green. So that's why red bandeds, we typically say they're more injurious than other native stink bugs. This is going to be why. They actually have a shorter proboscis, which is their mouth parts, but they send that proboscis deeper in the seed. So it creates more of a mechanical wounding channel as it penetrates the seed. Their length of feeding is actually less than southern green at 102 minutes versus 133. But as you'll see on the next slide, you'll see that their saliva is going to be more destructive, and you'll see the amount of area that actually these insects destroy. I know what Panizzi had found is their saliva is much more destructive than our native stink bugs, so that's why one of many reasons why our threshold is lower for red bandeds as opposed to native stink bugs is because it takes less injury to cause more damage. I guess if that makes sense. So they cause more injury per bite or per sting than our native stink bugs do. And then their saliva spreads and damages tissues up to 3.5 millimeters away. So you take that, a soybean seed is not real big. And so, if one piercing from a red-banded stink bug proboscis damages something 3 millimeters away, one bite can essentially take out half of that seed. And then your yield and quality goes down from there. All right, so this is soybean seed injured by red banded. So you can see there is a picture of stylets. So it's got the stylets with an arrow. That's actually what these guys do is when stink bugs feed on a soybean, they'll stick their proboscis in a pod, or they'll stick it through the pod into the seed, and they leave stylets. What stylets are is essentially pieces of the exoskeleton that are removed as they penetrate through the pod. And as scientists, what we can do is we can actually stain those with a different color, and then you can see them, and it gives us an exact entry point to where they went in and damaged the seed. So what these guys did, or what Lucini et al. 16 did, was they actually dyed the stylets, and then you can see where from that one penetration point how much damage was done from the red-banded stink bug. So this is just, you think about that, I don't think that's a probe. I think that's actually a feeding event. So, but anywhere that you create mechanical damage into a soybean seed, you're going to create an avenue for pathogens, secondary pathogens, fungal spores to come in. And then along with the damage that's done by the stink bug, you're going to also see seed rot when it comes in from the secondary pathogens. And then you get rain on top of that, like we've had the many years, since we've started doing this, and since red bands have come in, it seems like we get rain about every year we harvest, and then we see a lot of seed quality issues. And so that's an entry wound for moisture to get in and cause problems. All right, so going into cellular injury. So if you look, let's see. Okay, so cellular injury by red bandids. So this is the non-damaged seed. So what's circled by the red circle right here is a protein body. And so protein bodies are going to be what makes up a lot of your protein in a soybean seed. And that's what red bandids are typically going to be after. And so on the left-hand side of the screen, you're going to see non-damaged seed. And then on the right-hand side of the screen, you're going to see red banded damaged seed. And so non-damaged is circled right now, and then on the red banded stink bug damage side, that's what they do. So that chemical dissolution of seed tissues is going to be your primary cause of damage. So that chemical dissolution has caused that protein body to shrink, and then with that you're going to lose a lot of your cell content. You're going to lose the content of the seed, and then so that's going to in turn equate to yield and quality loss. And then there's another one that's, they absolutely destroy the inside of the seed. So that chemical dissolution of seed tissues causes a lot of damage. And that's something that, we see red bandids more than any other stink bug that we have, especially in Louisiana and the Mid-South. All right, so getting into management, I take this snapshot, I throw this up there at all the winter meetings that I do, because if you really look, this is out of our Louisiana Insect Management Guide. We've got 6 options there that compose 3 modes of action. You've got the organophosphates, the neonicotinoids, and the pyrethroids. That's really about all we've got. Now, there is something coming down the pipe from one of the companies that should hopefully be here in a few years that's going to give us another tool, assuming the EPA approves it, everything works out, that will give us another good tool in our toolbox, especially a rotation partner, but it's not here yet. And so we've got to use we have to utilize what we have. And so that's going to be really what we've got. We've got those 3 organophosphate, neonicotinoids, and pyrethroids. And so what I typically recommend our growers do in Louisiana is to budget 3 to 5 applications. Now, I know I've gotten cussed at a grower meeting in Louisiana because I said that. And because guys, the budgets that we have on soybeans are not, guys don't have a whole lot of wiggle room. Now, prices are getting better, but whether they hold, that's going to be a different story. But when you're at $8 beans, budgeting 5 applications for red bandids is almost impossible. So, but unfortunately, if you don't control these insects, they're going to take everything you have. And so it's one of those where you've got to control them. And so that's how I tell it to guys is if you budget it and you use it, that's great. It's in your budget. If you don't use it, it's even better because you've got money left over in your pocket, but you at least budgeted for those potential applications to be made. And then sprays on 5 to 7 day intervals. Now, this is going to be in a kind of a worst case scenario to where, you've planted late, you've got red bandids are getting ahead of you. You almost have to treat them for guys that grow cotton. You almost have to treat them like tarnished plant bugs, where we have to tighten our spray intervals to get them under control. Hopefully, guys don't let them get that bad, but if you get behind the 8 ball and you're 2 or 3x over threshold, so our threshold in Louisiana is 4 per 25 sweeps. So if you're finding 12 to 16, per 25 sweeps, then, you need to get them out fast. And so it's going to take more than one application of an orthene and a bifenthrin or one application of indigo or whatever. You're probably going to use more than one, and those need to be tight intervals to get them cleared out, or you can almost start over. And so I've had to recommend that a few more times than I care to really like. But the key is prevent colonization if possible. And so once red bandids get in your field and get established, especially as these beans are getting taller, insecticide deposition, depending on what nozzles you use, may be poor, especially if guys are running dicamba nozzles or some kind of ultra low drift nozzles. as entomologists, we don't recommend the use of dicamba nozzles for really any insecticide, period. Red bandeds, there's no exception, because you've got to get coverage. Coverage is key when you go to killing these insects, especially growing indeterminate beans where we've got pods sitting at the bottom and flowers at the top, because where a red banded's going to be when they infest a field of indeterminate soybeans? They're going to be at the bottom where there's something for them to feed on. So you've got to get your spray droplet down to the bottom and kill them. And so that's why preventing colonization, if you can, is going to be ideal, just because you're not already fighting an uphill battle. You're controlling the adults that are migrating in, and then hopefully they don't come in, lay eggs, really start going to town, because then you've got to really start getting after them. Cold weather. The colder the winter, the better it is. Now, you guys in the North Delta, Tennessee, up north Mississippi, Arkansas, typically don't fight red bandits very hard, whereas we do in South Louisiana, the northern part of Louisiana, south part of Mississippi, we fight red bandits pretty hard. Alabama's starting to see more and more red bandits now, especially in lower Alabama, and then Florida has been fighting them about as long as we have. So, my colleagues in the southeast part of the country, Clemson, over in South Carolina and North Carolina, also had producers that fought red bandits this year as well. So they're moving out of areas that normally do not see them. So to hopefully stop that, cold weather is key. And so, and when I mean cold weather, we're looking at, before I move on, I'm just going to show that I have the spine highlighted on this insect. So I'm going to table the cold weather for now. But to identify a red banded stink bug, what you want to do is flip that dude over, and he's got a prosternal spine. So basically where his proboscis, where his mouth parts are, meet where they come down and they stop on where his chest would be right here. He's got a spine that meets his mouth parts. Every red banded stink bug has got one, and that is the easiest diagnostic key to use. Don't use color. Don't use the fact they've got a red band across their back. Use that prosternal spine. And you can see that without readers on or some kind of glasses. You can see that with a naked eye, because these guys are pretty good size. Okay, so getting back to cold temperatures. Red banded stink bug super cooling point is -4 degrees Fahrenheit. So, and by the way, this work was conducted by Dr. Jeff Davis at LSU Ag Center. He is my research counterpart that is on campus, that is our soybean research entomologist for the state of Louisiana. So Jeff does a lot of great work, and let me present some of his work to y'all here today. And so, but the red banded stink bug, the super cooling point is -4 degrees Fahrenheit. So we're never going to see -4 temperatures here, especially in South Louisiana. So, that's the outright cooling point. Now, if you got to think about what the outright cooling position is, or how he measured that, that's not under leaf litter. That's not under, that's not in the environment. That's actually sitting in a super cooling, in a machine that does super cooling. It's basically sitting on a shelf, like sitting on this table, and having electrodes hooked to it, and they lower the temperature until it just freezes to death and dies. Red bandits don't do that in the wild. They don't overwinter on a parking lot or on concrete. They're not on a fence post. They're not on a tree branch. They're actually going to be buried in leaf litter. They're going to be on a lot of places that create a microclimate. So it's got to be cold. And that's where it comes with what he found is 23 degrees Fahrenheit. The lethal time for 50% of their test population was 4 hours. LT90 was 7. This is 23 degrees on something that's not under leaf litter or in a duck blind or somewhere out in the wild. This is going to be in a box where that was looked at. So it's got to be cold. I mean, we're talking, when we saw our lack of red banded, when we saw a lowering of red banded stink bug numbers in Louisiana, it was, I think it got down to 12 to 14 degrees when I used to live in Northeast Louisiana, and it stayed there for about a week. We never got above freezing for 5 days. That is the type of temperatures it takes to get red bandits under control, and we just don't see them down here. So at 32 degrees Fahrenheit, red banded stink bug needs to be exposed for a week to see 95% mortality. So that's kind of along those lines. If it stays below freezing for a week, then you can see some mortality. But if it jumps any time above freezing, which it does in the South, you're not going to see much mortality. So it's got to be cold. Okay, so cold weather aside, things have kind of, we're moving along. So, we're in the season now. This is some red banded stink bug foliar data. So this is some data that we run here at the LSU Ag Center. This is something I did at the Dean Lee Research Station in Alexandria. This is something we do every year. And basically what I do is I take a lot of the different options that we have, and we run them just to see how well they work efficacy-wise. And so you can see in the green on each bar is southern green, red banded is red, and brown is black. So as you see in each bar, each piece of the component, that's how many stink bugs we found, and then the whole bar is totaled. So, from this is 4 days after application. So, untreated control, we're running roughly 11 stink bugs per 25 sweeps, which is, about 2x, 2.5x threshold. Orthene at 3/4 of a pound is holding below threshold. I have the number 4 is our threshold, so that's that large black bar that you can see right there. And so that kind of gives you an idea of what's above threshold and what's not. Indigo ZC at 4.5 ounces worked fine. Bifenthrin at 6.4 works for now, but it will not work in the couple next slides. You can see why I no longer recommend bifenthrin at 6.5 ounces or 6.4 ounces by itself, because it might work and it might not. Most of the time it does not work. Imidacloprid by itself does not work at 4 days. Leverage works at 2.5 fluid or 2.8 fluid ounces. And what you have to see is imidacloprid and leverage are essentially the same thing, but a leverage has the addition of Baythroid. So where you pick up that increase in control is you're essentially tank mixing a neonicotinoid and a pyrethroid. So that's what is giving you better control. Same thing with indigo. Indigo is a tank mix or a jug mix of thiamethoxam, which is centric, and karate. And so that gives you those two modes of action help bring those levels down. Belay at 4 ounces is a neonic by itself. I normally get better control with Belay mixed with bifenthrin, but by itself it's doing fine. Lanate at 8 ounces did not work, or is not working here. But what you do see is where you mix bifenthrin and orthene, or bifenthrin and lanate, or bifenthrin and imidacloprid, that's by far some of the best treatments we have, and that will hold as we continue to move throughout the ratings. So if you look at 7 days, our numbers are skyrocketing. So our non-treated, we're running 20 red bandits per 25 sweeps. Orthene is gone. Orthene failed. Indigo, if it's at threshold, it's failed. So orthene's failed. Indigo is failed. I mean, we're at threshold again. That means we have to spray. Bifenthrin is toast. Imidacloprid already failed. Leverage is gone. Belay failed. Lanate failed. But what is holding, is the bifenthrin tank mixes, bifenthrin and lanate, orthene and bifenthrin and imidacloprid. And so what's good about the imidacloprid and bifenthrin is actually one of the more cost-effective tank mixes that we make. I think we did a cost analysis on that, and it's about $5 an acre for what we have down here in Louisiana. So it's a very effective treatment that is also very economical to make on your own. And then moving out to 13 days, our numbers started to crash a little bit in the non-treated, but as you can see, imidacloprid's still not working. Indigo, everything has failed already, but what still works is the premixes with bifenthrin. And so, with bifenthrin and imidacloprid being, numerically one of the best treatments that we have, and statistically. So just kind of keep that in consideration. That's something that we try to look at here. Is I've had a lot of guys with soybean prices, they want to go, the way that they can do the cheapest possible route, which I understand. Especially with guys that haven't fought red bandits much up in the North Delta. You guys don't want to break the bank sending money on insecticides, and I completely understand that. And so we try to help our guys, here in South Louisiana, North Louisiana, everywhere that we can, come up with cost-effective methods to control red bandits, because overall, that's what we're here for. We'll help make you guys more profitable, and to really help give you what's going to work the best. Okay, so something that we've looked at. This is some work that we looked at here a few years ago at the Ag Center. And so this is what the benefit neonic brings for red banded stink bug management. So if you look, our numbers aren't really huge here in this trial, but this is 4 days after application. And so that's adults and nymphs. So, we're running, 11 red bandits per 25 sweeps. So we're running about 2.5, almost three times threshold. Brigade is actually working pretty well. This is 4 days after application. This is Karaz, so Karaz is actually imidacloprid, and then Centric, which is another neonic, Intruder, which is a neonic, and Belay, which is a neonic. And so what we did essentially is our treatments are, we've got a non-treated, a brigade or a bifenthrin, which is brigade by itself. And then we have a brigade at 6.4 mixed with different neonics. And what this is going to show is the benefit that neonicotinoid insecticides bring to the table for red bandits in a form of what we call repellency. So going to 7 days, we're starting to see, not much change. Numbers kind of come down a little bit. We're at 4 red bandits per 25 sweeps. The brigade is still holding by itself. The brigade plus neonics are still holding. So, we're getting pretty good control out of these. Moving out to 11. So what we're starting to see is the brigade by itself is starting to fall apart. So we're not quite at threshold yet. We're almost there. But what we do see is the brigade in Karaz is doing okay, but not as good as the other ones. So where we mix brigade in centric and brigade in intruder and then brigade in belay, we actually see what we think or what we hypothesize is a repellency effect with neonicotinoids. And I've been able to replicate this in years. I replicated it last year, and then we also saw it this year as well. That where we get a neonic into the soybean plant, into the system, especially when red bandits are moving, they're very flighty. We see them immigrating in and out of fields. At least what we think is going on is that if the plant has got a neonicotinoid in it, so it's a translaminar product, it's going to move in the tissues. If a red banded stink bug comes in and probes and it doesn't like what it tastes, it's going to fly away. Now, it's probably not going to be enough to kill it outright, but it's still enough of the chemical, enough of the insecticide in the plant tissue that when they come in, they're going to probe. So they probe to figure out where they want to feed, to find a feeding site. That comes in, it probes, and it hits a spot that's got a neonicotinoid in it, then it picks up and flies over to your neighbor's field. So we've seen that, and typically based on that, I try to recommend guys, especially their first shot out of the gate. So when red bandits, when they're making their first application, they use something with a neonicotinoid in it, whether it's an indigo or a leverage, or you make your own, whether you use a midicloprid tank mix with a pyrethroid. That's typically what I recommend. It's cheap. And it does seem to help, at least it seems to reduce the level of colonization that we see. Now, it's not going to be a season-long fix, but it does seem to delay the amount of adults that come in and set up shop in our soybean fields, so that we can at least get a little bit more time to get down the road where we're not have to control them every single week. So, and we do see that, and I've had confirmation from consultants and growers, at least in Louisiana, that seem to really that has worked for them, and that's something they seem to want to do in the future. So I'm just throwing that out there. Okay, so desiccant by insecticide. So looking at so this is something that we do in Louisiana. We recommend typically, especially with the amount of hurricanes that we face, that we recommend adding a desiccant with adding insecticide with our desiccant. And so what this trial looked at is just looking at whether we use acephate or lanate. So in Louisiana, we have a 2-pound use rate for acephate. So, we get 2 pounds and that's it. And a lot of times we use that up very quickly, depending on where you are. So a replacement for acephate is lanate. Lanate has the same PHI. It's the same mode of action. It's just lanate is a whole lot more toxic than acephate. So if you're new to ag, if you're one of the so-called Roundup babies, which is what I get called because I didn't know farming without Roundup, you may not use the really toxic stuff that some of the older guys like my parents, my dad used, and my grandparents. So just be aware that if you decide to use lanate is skull and crossbones, and it is very toxic. So just read the label, be aware. It's not like throwing acephate in there. You need to give this stuff a healthy dose of respect because it is very toxic. But looking at the 7-day and 14-day pre-bar is black, 7-day is red, 14-day is green. Pretty much where we used a pound of orthene, a pint of lanate, half pound of orthene, half pint of lanate, it all worked. So it kept numbers below threshold and it worked well. That was adults. So looking at nymphs, we were running high numbers of nymphs. Our nymphs were well above threshold in a lot of our plots. And so, but even 14 days after we made the application, it kept it below threshold. Now the numbers did drop after our pre-counts and the check as well. So, but what does matter is that what we use, it does work and it does kill red bandits. And so that is an option if you decide to pursue that. Okay, so moving, just kind of wrapping up with 2020 management considerations. Plant early. What I typically recommend our growers in Louisiana to do is we plant early. Now, I have that with considerations. Planting early is important because you can outrun a lot of insects when you plant early. But if you're the first person out of the gate, so if you plant the first week of March, like in your area, and you're the only soybeans for 3 weeks, your soybeans are going to be the first ones to mature in 3 weeks, or when that time comes, by 3 weeks or a month, down the road. So red bandits are going to jump on you first because you've got R5 soybeans that are ready before anybody else. And so take that into consideration. I'm never going to knock somebody that's going to try to plant early because I think more times than not it's going to be beneficial. But it is something that we have seen. I've definitely seen this here. The earlier maturing varieties that we plant that are ready quicker, red bandits are just like they're waiting at the starting gates to just start and colonize. And so we had some atrociously high numbers and some very early beans that we planted last year or the year before last. So just take that into consideration. If your neighbors are plan on planting, the second or third week of March or the first week of April, and you've got a good block of beans around you that's going to be ready about the same time, you should be fine. Just don't wait. Try if you can, and I know there's a lot of factors that go into this. Try not to wait till the first week of June to plant soybeans if you can, just because you're going to be fighting stink bugs from can till can. And then going on the opposite spectrum of that, if you're one of the last people to plant, what you have is what we call a green island. And so if you plant the second week of June and everybody else around you has already harvested their beans and you're the only one that's left green on the block, then you've created a green island for all the stink bugs in the world to come to you and start feeding. So, and I've seen that happen many times. So try to be in the window when a lot of your beans are going to be early, but try to be, if you can, be where the majority of your beans are going to be planted with your neighbors around you if you can. So just take that under consideration. Colonization means you're already behind. I tell guys that if you're finding immatures, and I have nymphs are the decision maker. So if you come in, you've got immatures running around. Immatures can't fly, which means that they were born on the plant or they were born in the field that they're in. So if you find nymphs, that means your beans are colonized. The adults have come in, the male and female have mated, she's fed and laid eggs, and then you're finding nymphs out there. That means they're feeding on your beans out there causing damage. So if you're ever on the fence about making an application, I get guys that ask me all the time. I've been at sub-threshold for a week. I'm running 2 red banded, 2 to 3 per 25 sweeps, and 2 of them are nymphs. Spray that field because nymphs can't leave. And so, especially the larger nymphs are going to do a lot of damage. And so if you're running sub-threshold levels for an extended period of time, clean them out because sub-threshold populations will increase in injury. And so, if you're ever on the fence and you're not at that magical 4 per 25, like I said, it's a recommendation, nymphs are going to be the decision maker. And so just like when we're controlling plant bugs in cotton, you got immatures in there, that means you need to get in there and clean them out. And indeterminate beans may require modified scouting practices. What I mean by that, get low in the canopy. If you got to get on your hands and knees or get down there with a sweep net or even a drop cloth, get down there and look because they're going to be on beans at the bottom of the canopy that have pods on them and they're going to be feeding hard on those. So, and with that, this is my contact information. So this is my email and my cell phone number. And so if you guys ever have any questions or concerns, like I said, I will be happy to help you guys in any way, shape, or form I can. And, all of us entomologists in the Mid-South group, we all work together and we come up with a lot of protocols. So we're all on the same page. So, like I said, all of us are willing to help. And like I said, we're all kind of attack the same problems because we all fight the same issues in the Mid-South. So with that,
we could use a few more minutes. You want to talk about maybe some projects that you're trying to do?
Okay. So as far as, I guess, what David we're trying to talk about a little bit, a few things that we have going on in the future. So what we're looking at, I guess, as my program, and then I know my colleague, Dr. Tyler Tolles up in the northeast part of the state, we're looking at the impact of cover crops on red banded stink bugs. And so this is it's an important component because cover crops are becoming a lot more popular across the Mid-South, especially in Louisiana. And then what's going on is we're starting to see legumes really start to pop up and become a major component of that cropping mix. And so Dr. Davis has done a lot of good work looking at the preference of different cover crops. So looking at crimson clover, looking at different types of clover regimes, that how attractive they are to red bandeds. And I know what he found was crimson clover was the most attractive to red banded stink bugs. And so what we're trying to look at is what causes the trigger for them to leave. So is it desiccation? Is it, depending on what's going on out in the field, is it, we're going to look at preference as well. We're going to try to repeat that study, but we're also going to see what cues cause the red bandits to leave. And so that's something that we also really, I get a lot of questions, and I didn't elaborate on in this talk, is that with cover crops gaining in importance, guys always ask me, do I need to kill red bandits in my cover crops? And it's a hard answer. That's a hard question to answer because, cover crops are not supposed to be really money intensive. I mean, they're supposed to be something that's going to help your cash crop. And I don't want to see guys spend a whole bunch of money in these things, controlling insects that may or may not potentially become an issue. So now we know red bandits are a problem, but is the red banded if the red banded that you see in your cover crop in February, is it going to be feeding on your soybeans in June or July? That stink bug, no. That same stink bug is not going to, more than likely, is not going to be feeding, is going to be the one that you're going to have to kill in your soybeans. Now, it comes into, you're putting a lot of red bandits in the environment. And so now, do we need to kill them in the environment? I want to see the least amount of red bandits go into overwintering or what we fight in the spring as humanly possible. I mean, because that's less we have to face. The problem is, if you plant 500 acres of crimson clover in an area and you're the only one in the county or the parish that's planting crimson clover, you may have a concentration of red bandits right there on your spot, but you've got, like in Louisiana, we've got white clover and crimson clover along almost every ditch bank and roadside, bordering every field and going up and down every highway. And so by you killing the red bandits in your crimson clover and your cover crop, then, you may be doing something now, but in the long run, is it helping you? Probably not, because we've got so much other forage out there, so many other legumes that red bandits are going to be attracted to, that you're going to be recolonized on those same 500 acres from, the area around you. So, kind of long story, I wouldn't put too much faith into, trying to spend a bunch of money killing red bandits and crimson clover on your farm, especially if you're the only one growing it. Now, if you and, all of your neighbors are doing it and you've got, 50,000 acres, that may be something, worth looking at, but it's not that popular, at least not in Louisiana yet. And so I typically don't recommend our guys doing that because I don't have the data to show the direct benefits of killing red bandits and crimson clover that's going to help reduce your insecticide sprays in the fall, or in the summer. So,
there was some talk when I came in January or February. There was some talk about, should we be worried about damage early in the growing season? You mentioned a little bit about June.
Yeah.
There was talk about doing some research on testing for early damage. What do you think about that?
So, early damage is I would say early damage, it has the time and the capability of developing worse as the season goes on. So, and it depends on when it happens in the growing stage. So early damage, let's say if you said damage at R5, when the seeds are just starting to form in the pod. If a red banded stink bug comes in and pierces that seed and kills it, then that's going to never form into a seed. So, early damage, I would say, is going to be more detrimental than late season damage, just because, you take damage at R5 versus damage at R6.5. 6.5, you've got fully formed seeds in there. R5, you've got seeds that are the size of a BB. And then they come in and they drill that seed. That seed's aborted and it's done. There's no there's no recovery. There's no, I mean, yeah, you may take a hit in quality, but you've still got that seed that will contribute to oil content and yield. So,
Okay. So 2 more questions on that. So at what point do you think it's safe to not spray? Like after it's dried down to 13%, or?
so what we tell guys, and what I typically tell guys, that you spray red bandits until they're in the hopper. I mean, and this is something that we've seen in the past. And red banded stink bugs are one of the few stink bugs that will actually cause damage even late season. So they'll cause where, our native species don't cause as much damage late season, red bandits still can, because they have those detrimental enzymes, and they also have those larger mouth parts. And so something else too is that I've gotten a number of just instances, now granted these are anecdotal, these are instances, but phone calls where guys have been docked for foreign material because of stink bugs. Literally, stink bugs they hauled with them to the elevator that, I mean, they're, the elevator counted them as foreign material, which they are, because it's not a soybean. I mean, it's a, and I've ridden in combines with guys where, I mean, you can't see the head on the combine because it's covered in stink bugs. And so now the beans look good, the quality's good, but there's just stink bugs everywhere out there, and there's just filling up the hopper with them. And another consideration, just our weather is so unpredictable in Louisiana. I mean, David's first year he got to experience 2 hurricanes, and this was I've been in Louisiana for, over about, 12 years now. And this is the first time I've experienced 2 direct hits, from us up in Alexandria, which was just kind of unusual. But at the same time, I mean, we fight hurricanes, and weather exacerbates stink bug damage. So if we have a hurricane coming, we get 10 inches of rain dropped on us, and you've got soybeans that are ready to harvest, those soybeans are out there unprotected, and red bandits don't stop because of rain. And so, killing, and I put a tweet out about this, and I normally, if you're on Twitter, you can find me, you follow me on Twitter, give my shameless plug on social media. I put a tweet out about before we had Hurricane Laura hit us, that you guys need to spray if you're thinking about desiccating beans, you absolutely need to add something in with it, because you've got to protect those soybeans, and while they're out in the field. Because if we get 8 inches of rain and you're on, heavy clay and you're not going to get in there for 3 weeks, you can absolutely believe that red bandits are going to be there just hammering on those soybeans. And so, and your quality is going to completely go downhill. So don't sacrifice everything you've worked for the entire season and not add that extra just ounce of protection towards the end. And that's typically how I like to tell guys to do that.
So one last question. You mentioned spray at R5 versus R6 or in the hopper, but I heard one question about should be concerned about R1, like in a flowering stage or so.
So the data on that, I actually had a test that didn't work out this year. Hopefully it'll work out next year, that we were going to actually address that, and the stink bugs didn't play ball with us. What the research says is no. At R1, and what the data says is we don't see a significant yield impact from spraying stink bugs at R1. But on the flip side of that coin, and we do know red bandits feed on stems and petioles and leaves. They will, while there is no fruit structure there, they will be there feeding and probing. So Panizzi, I didn't add that in this talk, but Panizzi has shown that in some of his research. And so what that may contribute to him is green stem syndrome. And so if you've got a large number of insects that are in your soybeans at R1, I mean, you're at threshold level numbers, and they're sitting there, and it's a hard call. It really is. I mean, I hesitate to tell guys to make applications at R1 for red bandits, but at the same time, those stink bugs do have the potential to hang around in the area long enough where they could be doing, damage in the form of green stem syndrome, and damage we don't really understand, that I can't speak to because we don't know. I don't have the data to say, but I think they're doing something. I just don't know what it is. And then 2, they very well be there when you start to put pods on, with size on them. So, depending on how hot, temperature, day length, all that. So, I would say that I wouldn't get in a hurry about making an application, but if they're hanging out and it's making you uncomfortable and you've got it in the budget, I would think it would be potentially something to at least consider.
Maybe stay away from the bifenthrin.
Yeah,
first?
yeah, it would be. It's just I have a hard time because it's just I don't know. It's really it's one of those questions where it's not. Are they going to directly hurt yield? No, because there's no yield for them to hurt, or at least that we know.
Yeah.
I mean, are they going to hurt pods that aren't there yet? I mean, no. And the research says no, they're not going to be there. But we all know anybody's been in the field has seen red bandits in R1 soybeans, especially in Louisiana. So, and I know guys want to control them, and I don't want to necessarily talk them out of it. But also, if your budget is razor thin and you need to save, if you've got, which nobody has extra money to burn, but if you've got a razor thin margin or you've got a budget where you've got to pay rent and everything else, don't spray at R1 when you can save that insecticide to spray at R5, R6, because that will directly protect yield. So that's really how I like to phrase it to those guys, is that save it where it will directly protect yield. If it's just, got a burr under your saddle where you've got to get them out of there, then I don't think it's going to hurt, but just know that I can't exactly tell you what the benefit from data is going to be. So. Alrighty, well, I think that's what we've got. I appreciate y'all taking the time to listen to us, and it kind of worked out because it turned into a question and answer session. So, alrighty, thank you. All right, so you guys, I know we didn't neglected to do this, and that was my fault. I'm sorry about that. So this is for CEUs. So you've got an option here. I'm going to sit here. I'm going to give you plenty of time to look at this. So but I'll read it to you. So if you want to apply for CEU, scan the QR code on the next screen or go to that link. You have to enter your name, tracking number, or certification number. And then there is the QR code. And I know you've got there's the CEU tracking number and everything else you need. So go ahead and leave that up for a minute. That should be good. All right.